in this video, we are going to discuss the problem queries on a matrix. So in this problem, it is given that you are given with a matrix of dimension n into n, means the number of rows and number of columns are equal. All the cells are initially 0. You are given q queries which contains 4 integers a, b, c, d. The task is that you from index a comma b to c comma d, this is a rectangle which is formed inside that particular matrix, and you have to increase the value of all that sub matrix by 1. So let's understand the query, that what is the query is asking us. The initial value of our matrix is 0. This is what is given to you. So let's check that what is it asking to us. So if you will just consider a matrix, let's consider a matrix and create one. Okay, so let's take that our matrix is something n is 4, or the value of n is 4. So our matrix will something be like 4 rows and 4 columns. So let's create a matrix of 4 rows and 4 columns. Okay, so for that, first we have to make 3 partitions, 3 lines of partition, which will make 4 partitions basically. Okay, the 4 rows and similarly the 4 columns. First column, the second column, the third column. This is a matrix, let's say. Okay, in this matrix, what we have, we know that this is a 0, 1, 2, and 3. This is our 0, 1, 2, 3. Okay, now the thing which we have to observe is that in this particular matrix, which is something like this is what we have to basically coordinate. Now the main task, the main thing we have to do is that, let's say that the value of a, b, c, d for each query which is given to us is 0, 1, and let's say 2, 3. So that means that from index 0, 1 to index 2, 3, there is a submatrix which is present. There is a submatrix which is present. This is a submatrix from 0, 1 to 2, 3. Okay, and in this particular submatrix, you have to increase its value by 1. You have to increase the value of that submatrix by 1. So this is 0, 1. Okay, this part, this particular part from here, and this is 2, 3. So means in this submatrix, so currently all the values of this matrix are 0. But for this particular submatrix, you have to increase its value by 1, and the rest will be 0, 0. Similarly, we will have different queries. So let's say that a query now is 1, 0. Okay, to let's say 3, 1. Okay, so 1, 3, 0 to 3, 1. Let's say this is the query given to us. So the submatrix which will be formed is something like here. So it will start from 1, 0, which is here, to 3, 1, which is here. So we will increase the value of each and every component to by 1. So first of all, these zeros will become 1, and these ones will become 2's. It will increase the value by 1. So this is what we do. So here it will be 2, 2. Here it will be 1, 1, 1, 1. Okay. Now the task is how we can perform this thing. So let's don't focus on the 2 queries. Let's focus on the 1 query. If you are able to perform the operation of 1 query, obviously it means if you are able to solve the 1 query, you can solve all the other queries. So if just focus on the first query, which was 0, 1, 2, 3. Okay, so was the first query which is given to us. So after that query, our resultant matrix was something like this. So here it was like 1, 1. Here it was 0. Okay. Now the brute force approach for performing this thing is that you have just iterate from this particular index to this particular index, and that will take a complexity of O n square. And let's say if there are q queries, then for all the q queries you have to perform this by q times. So the overall time complexity will be O q into n square. So this is the time complexity for a brute force approach. That is a very simple brute force approach, that you have to just iterate from this a comma b from A, comma B to C, comma D. This is what we have to do. But we will try to do this thing in an optimized manner, in a more efficient manner. So for that thing, what we will do is, you all have learned about the prefix sum technique. So if we have to make this same thing, we have to do the same thing in an array, then what we will do? Let's say that this is an array we have. Let's take an array. Okay. Let's say that here you have to increase the value from this particular, for this subarray, let's say. From index, if this is the indexing I am doing here. So from index 1 to 3, you have to increase the value by 1. Means currently they are 0, but we have to make this value to 1. So initially they are 0. They all are 0. Okay, they all are 0. Now, to perform this, the first brute force process, just we have to iterate from 1 to 4. But that is what, that for each and every query, you have to iterate from the index I to index j, if you are considering I and j as your subarray. But if you have to generalize it for several queries, what you will do, that you will increase the value of this 1 by 1. You will make it 1. That is because your subarray is starting from here. And then the index where the subarray is ending. So subarray is ending at index number 3. So you will make the index number 4, means 1 greater than that to minus 1. And then if you will find the prefix sum, or basically if you will just like you find the prefix sum, similarly if you will just add the value of a previous cell to the particular cell, then that value will be equal to R required sum. You can see, if I will just write that A RR of I is equal to, yeah, or we can just write it like this, plus is equal to ARR of, let's say, I plus 1. So means, or I minus 1, sorry, it's not I plus 1, it should be I minus 1. Okay. So means, uh, so means in this I, 0 will be added. So it will be 1 only. In this 0, this 1 will be added. It will also 1. In this 0, this 1 will be added, because now second index is also 1. It will be 1. And in this 4, this third index 1 will be added. So it will be 0. So at the last, you can see your array is something like 0, 1, 1, 1, 0. And that is the required array we are doing. But in this matrix thing, in this case of matrix, we have rows and we have. So what we will do, we will do this same technique, we will perform the same technique, but for rows and columns separately. And then we will merge that to matrices. Okay, so let's see how we will perform that thing. So for that, what we will do, we will take 3 matrices. Okay, we will take 3 matrices, one for our original matrix, that is going to be the answer. Okay, and the other for the other cases. Let's see how you are doing that. Okay, so let's just copy this matrix. Okay, and we will just consider this matrix and take this matrix. Okay, so let's take this matrix and let's understand how we will perform this similar operation for the other cases. Okay, great. So this is our matrix. Let's create 2 duplicate matrix. One will be for row and other will be for column. These are the 3 matrices we have created. Okay, so initially the value of all these matrices will be 0, 0, 0 only. The value will be 0 only. Okay, it will not be something else. So we will just change the value, okay, of all this to 0 in a star. Okay, also one more thing, guys, that you will take the size of this matrix, one more than the value of n. So because you can see that in this matrix there are 4 columns and 4 rows, means the value of n is 3. So for value of n is 3, you will create matrix of size 4. Now guys, what we can do now, that we can just delete this thing. Okay, we can just take duplicates of this particular matrix. Okay, and we can just have 2 different matrices. Okay, so let's name them. That this first matrix which is given to you is, let's say it is the original matrix. Okay, where we have to perform the operation. Okay, so the first matrix, which is this one, let's say it is just matrix. Okay, the second matrix is, let's say, row, and the third matrix is, let's say, column. Or let's write it like this. Okay, what we will do, that if we have to let's take that same array case, that is we have to start from 0 comma 0, let's say, until 2 comma 1, we have to increase the value. So means from 0 comma 0 to 2 comma 1. So first we will do this thing for the first case, means for the row. Okay, so for row, what you will do is that we will start from 0 comma 0 and till 0 comma 3. So from 0 comma 0, which is this one, will increase its value by 1. Increase the value of 0 comma 0 by 1. Okay, so what we are doing, we are increasing the value of row A, B by 1. So we are doing plus plus. Just remember this method. Okay, this is what we are going to implement. So this is A, this is B, this is C, this is D. We all know. Okay, now the next thing is that we will, because we have to just make it till index number 2, till row number 2, from here to here only. As I told you in the array case, similarly here we will decrease the value of this third row, 0th column, because we don't want to extend our incremental here. Okay, so it will be row, it will be C plus 1, B will be minus 1. So what we will do, we will just make this value of 0 to minus 1. So this will be now from 0 to minus 1. So this is the changes we are doing in this particular row matrix. Okay, now similarly for the column matrix, the things are quite reversed. For column matrix, what we will do, we will increase the value of column C plus 1, D plus 1. I will tell you the reason why. Because we have to also stop our decrements, and we will decrease the value of column. So that for a decrement, what we will do, we will decrease the value of column A, D minus 1. Okay, so the reason is that, let me just define the reason for you guys. Okay, so the reason is that this is so A is 0 and D is 1. So this particular is what is A comma D plus 1. It will be D plus 1. Okay, so this will be minus 1. The reason is that we have to just consider this particular submatrix. Okay, starting from here and here. So the index which is just after this, which is this one, this should be minus 1, and this one, this also should be minus 1. And here it is 1. And we will increment the value of C plus 1D. So C plus 1D will be something like C plus 1D, D plus 1 is something like 2 comma 3. Not here, it should be here. Just gone wrong. So it should be here, and we will increment this value by 1. Okay, fine, great. I think that we have done something wrong. Okay, so it will be 3 comma 2 now. Yeah, so it will be here only. Sorry, that is what we have done wrong. It is because you can see that in this same row we have a minus 1 here and a minus 1 here. That is why they will not coincide. We have increment this value by 1. Now if you will do a prefix some row wise prefix in these rows, in this row and column matrix, not this matrix. So what you will achieve? You can see one thing. You can just see one thing, that this complete row will be, this will be 1. So this 0 will become 1. This 0 will become 1. This minus 1 will become 0. And else will be 0, 0, 0 only. Similarly for this case, it will be minus 1, minus 1, minus 1, and here it will be 0. Oh, sorry. Here it will be 0. Okay. This is what we have to do. Now, the next thing that we have to observe here is that how we have to just now continue this process again. So now what we will do, we will just make a prefix sum column wise, but while making the prefix sum we will also add the values of this row and this column, and that we will do in this matrix. Okay, so first what we will do, that we will copy the values of the first column of this row and matrix in this, the sum of that. So the first column will be copied, so it will be something like this. It will be something like 1 1 1 0. So it will be 1 1 1 0. So the value of this first row and first column, the sum of them are copied, and then now we will perform the prefix sum column wise. Okay, so it will be something like that. You have to just take the previous value and add the current value of this row and row. So if I will just take the previous value, current value, so it will be 1 1 1 1. This 0 will be gone, and here it will be minus 1 minus 1 minus 1, and it will be, so now from here it is minus 1 and it will be 1, so it will remain 0 only. This will remain 0 only. Okay, because here the previous value was 1 and in column we have minus 1, so this value will be 0 only at last. Okay, so this is how you can see that we will just got a required matrix to be, and here it will be 0 only, but it was 0, here it was 0. Okay, and you can see that for this submatrix we will have 1 1 1 and the rest starts 0. Similarly, we can perform multiple queries using this technique. Now let's move towards the code part, how we can code the implementation which we have discussed now. Now let's implement the logic which we have thought. So as discussed, we will create 3 different matrices named matrix, row and column that we have discussed in our approach, and the size of that matrices, basically the thing is that there are many corner cases, like somewhere we are just finding the I minus 1 index, sometimes we are finding the I plus 1 index. So to avoid that thing, we will take the size of the matrix as n plus 2, so that this thing can be avoided. So what we will do, we will take 3 matrices, first named matrix, then named row and named column. Okay, this is the thing which we have done. Now as discussed, what we will do, we will just input the queries. Okay, so the queries are given in the form of a 2D vector, so we will just iterate through the queries and we will implement the exact logic which we have discussed. Okay, fine. So now what we will do is that we will just iterate through this particular queries. So for that we will use the for. Let's take iterator, let's say it, sorry, and we have to iterate through queries. Okay, now we will take A will be that first index, B is the second index, then similarly we will find the values of all the. Now as discussed, what we have discussed in our approach, you can see here that this is what we have discussed. With the values of this A, B, C and D, we have to perform these 4 operations. First, row of A, B plus plus, row of C plus 1, B minus minus, column of C plus 1, D plus 1 plus plus, and column of A, D plus 1 minus minus. So these are the operations which we have to perform here with these values of A, B and C, D. So for that operations, what we will do, we will just write that inside this queries, okay, inside this loop of queries. So you can see that here I have implemented these 4 operations which we have discussed in our project. Now after this, what we have discussed was that we have to find the prefix sum row wise. That is what we were finding. So for that, for the row wise prefix sum, what we will do is that we will just for each and every row, for you can say for each and every column, we have to do row wise prefix sum. Okay, that is what we have to do. So for that, what we'll do, the first value will be from, let's say, int I is equal to 0 and I will be less than n and I plus plus. And to avoid the corner case, we'll start j from 1. Okay, and j is less than n and j plus plus. Because the operation we have to do is row ji, I is the column number actually, plus is equal to row j minus 1, and the similar thing we have to do for, okay, this is what we have to do. Now, after that, what I have told you, so let's again move towards the logic which we have just performed. After that, I have told you that after doing this operation on row and column, what we have to do was that we have to just copy the sum of the first column of row and column to matrix. Okay, so that it can help us in the prefix for the pre-calculations. Okay, so what we will do that for the first row only, for the first column, sorry, what we will do, we will just take, let's say, from I to n, and then what we will do that value of our matrix I0, always for a zero column, it will be row of I0 plus column of 0. This is what we have to do here. Okay, this is what we have to do here. Now what we will do, as I told you that to find the value, what we are doing here in the logic, you can just check it here. Okay, what we were doing was that for this matrix, what we are doing, we are adding the previous value in the previous column plus the values of our row. This is how we are making the prefix sum that we have discussed in logic. So similar thing we will do here. Okay, so but before moving this, first let's just find the value. Okay, so we have to now do the column wise prefix sum. Okay, so now the value of I, let's say, will be as expected. So now what we will do that we will take a for loop from I is equal to 1 till I n plus, and this will be for the jth loop, it will be from 0 and j plus plus. Now the value of matrix ji will be equal to, or we can say like this, will be equal to matrix of j minus 1. Okay, oh sorry, ji minus 1, because here the column wise is there. Okay, and now the value of rho jj ij plus, sorry, ji, so rho ji plus column ji. This is what now we have to do. Okay, and then the thing is that if you will just focus on your problem, so we have to return a vector pair, and obviously that vector pair should contains n rows and n columns, but here we have our matrix as n plus 1. So what we will do, we will create another vector. So in that vector we will just copy the first n rows and columns of this. Okay, so for that, first we will create a empty, let's say, a result vector. Okay, and in that result vector we perform this thing. So the result vector is this, let's say. Okay, now here what we will do that we have to just copy. So for that, let's take this type of loop only, that is the nested loop which we have to take. That will be from 0 to 0 only, and remove this thing. So the value of result ij will be equal to matrix ij, and then we will just return this. This is basically what we have to do. This is what we have to do. Now let's move towards the submission of this problem. Let's see, compile this code. You can see it has got the right output. Let's submit it. So all the test cases are passed. Now, if we talk about the time complexity and space complexity for this particular solution, so if we talk about the time complexity, so time complexity for this solution will be order of n square only. So in our brute force approach, the time complexity was n square into q. Q is the number of queries, but here in this case the time complexity is reduced and it is optimized to order of n square. Similarly, our space complexity is, because we have taken three matrices basically, but then also it is only order of n square because that is constant, so it is just order of n square. So this is the time complexity and space complexity for this problem. I hope that you have got this problem. Please comment if you have any query, like this video, subscribe to the channel and share this video with friends. Thank you.